Welcome to Matematika. Today we're going to do review questions and solutions in chains and tandem. We're going to start with the first set. For each function, identify what the dependent and independent variables represent. So if you try to look at the questions, g of a, d of m, and k of t, you are given a function notation. If you remember on what I said about the function notation, right? If you are given, let's say, f of x, the x here is the input and the f is the output. So when we say input, that is the independent variable, okay? And the output is the dependent variable. So where we can find the independent, that is on the x-axis, and the dependent is on the y-axis. So for number one, the g of a is a function where g is the amount of liquid absorbed by the paper towel, and a is the brand of the paper towel. All right? So here, A is the input. Okay? Input is the independent. That means our independent is right here. All right? That is the brand of the paper towel. It's easy. Right? All you have to do is to look at the function notation, then you know right away which is the independent and dependent. So in other words, the dependent here is the amount of liquid absorbed by the paper towel. Okay? Amount of liquid absorbed by the paper towel. Okay, let's do the second question. D of m is a function where m is the wavelength of light and d is whether the light is observed. All right? So m here is, what do you think? The input or the output? M is it's right here. That means it's the independent. All right? And D, this is D of M. D is the dependent. All right? So, in other words, the independent here is the wavelength. Wavelength of light. And the dependent is whether the light is observed. All right, let's have the third one. Sorry for that. K of t is a function where t, okay, is time spent on the phone, and k is how much studying is done. Okay, so t is the independent, that is time spent on the phone. So the more time you spend on the phone, I guess the time for studying is affected, right? So the dependent is how much studying is done, because you know the more you are spending time on the phone, the less time you have for studying. Okay, let's go to another type of question. In B, state whether the function is increasing or decreasing on the given interval and justify your answer. Okay. If you look at the table, you are given a table. If you look at the table, this is the f of x and this is the x. That means this is the input and that is the output. All right? In, out. Okay. So the interval from 1 to 5, if we look at the interval 1, when it's 1, it's 100. When it's 2, it's 80. 3 is 70. 4 is 45. 5 is 10. So if we look at our input values from 1 to 5, it is increasing. If we look at our function, f of x, the output, from 100 to 80, 70 until 10, it is decreasing. Okay? Decreasing. Right here, it is increasing. So, what does it say? If the function, remember, I would say if the function is decreasing, function f is decreasing, on the interval. Let's look at some interval here. Of x, that is from 1 to 5. Oops. This is 1 to 5. All right, 1 to 5 here. Because for all, A and B, meaning point A and B in the interval, if A is less than B. Okay, so for example, this is A and this is B. Our A is 1. I will choose 1 and I will choose 2. So isn't it 1 is less than 2? That means A is less than B. Okay? So in this case, the A is less than B. So what happened is that the function of A is greater than the function of B. What is our function of A? 100, right? F of A is 100. What is our function of B? Our function of B is 80. Isn't it 100 is greater than 80? Right? So that means our function is decreasing. If that is the case right here. Our inputs, A less than B, but the function is greater. So it doesn't, one is decreasing, the other is increasing. That is what I'm saying. So the input is increasing, Well, the output is decreasing. If that happens, that means the function is decreasing. Okay? Let's look at letter B. Let's look at the input first. Here, 10, 12, 15, 20, 35. So what can you say about it? It's increasing, right? So in this case right here, what can you say about the A? Let's say A is 10, B is 12. That means our A, if this is A, this is B, our A is less than B. All right? Let's look at the f of x. That means the output. So when A is 10, the f of x is 4, 3.8, 2.3, 1.8, 0.7. That means it's decreasing. Okay? So our f of x, when it's A, it's 4. And when it's B, it's 3.8. So that means our f of A is 4, and the f of B is 3.8. That means the f of A is greater than the function of B. So in this case, is it increasing or decreasing? Still, the function is decreasing. All right? One is increasing, the input is increasing, but the function, the f of x, the output, is decreasing. So our function is decreasing on the interval. So what is our interval here? From 10 to 35. Right? It's decreasing. So because for all values of A and B, so let's say if I make 12 as A, the B would be 15, and so on and so forth. So for all A and B in the interval, let's say if A, in our interval here, the A is less than B, that is 10 less than 12. Okay? Is it in the interval? And in the interval cannot be read. Just follow on what is written on the statement. If in the I do it twice. Okay, in the interval, for all in the interval, if A is less than B, then look at the function of A, which is 4, and the function of B is 3.8. That means 4 is greater than 3.8. So the function of A is greater than the function of B. So that means our function here is decreasing. So you might think, oh, when can I say it's increasing? Okay, that is your question. Let's look at the table C here. Okay. So if we look at the input value, input is x, all right? Input on f of x is the output. So the x is the input and this is the output. Right there. Is one from 101 to 501, it is increasing. Okay, increasing. Let's look at our output. 10, 11, 12, 13, 14. Increasing, decreasing. It is also increasing. Okay? So, you could say F is increasing. So, on the interval of, what is our interval here? Let's look at the A. From 101, between 101 to 501. That's our interval. Because, you just follow the statement. Because for all A and B, okay? So for example, I'm going to use 101 as our A, okay? And 201 is our B, okay? So what can you say about the interval from A and B? So in the interval, okay, in the interval, if A is less than B, so the A is less than B, right? So then the function of A is also, what can you say about the function of A? When it's 101, the f of A is 10. And the f of B is 11. That means the f of A is less than f of B. Okay? So both of them, our A is less than B, so our f of A is also less than B. That is our output value. Okay? Both are less than, from A to B, A to B. But if you look at the pattern of the table, when both are increasing or when both are, less than, if in terms of interval and function, that means our function is increasing. But in one interval, one is decreasing and the other one is increasing, then it is decreasing. Okay, I hope it's clear. Okay, let's look at in terms of graph. Letter D. Okay, what is our x here? This is our x. This is our y, right? F of x, right there. So our interval, let's say our interval is here. So our interval is 2 to 9. Okay. By looking at the graph, going up, it's increasing. Right away. So the function here is increasing. But we try to justify, because you're asked to justify the reason or justify your answer. why you say it's increasing, and why you say it's decreasing. So I would say in the beginning that f is increasing. This is how I will justify it. I know that it's increasing on the interval. So that's how you start. On the interval, what is your interval? Between from 2 to 9. Okay? 2 to 9. So what is in between 2? 3, 4, 5, 6, 7, 8, 9, 10, up to 9. That is what we mean by the value of x is between that 2 to 9. That's the interval. So because, okay, I will say because if something like this will come out in the test, in AP Precalculus exam, then you could start saying your justification like this. F is increasing on the interval of, you give out the interval because for all A and B, so you could start saying that in the interval. Okay, in the interval. If, what can you say? If this is A and this is B, that's your interval. A and this is B. Isn't it? If A is 2, B is 9. So what can you say about the A? A is less than B, right? So you could say that A is less than B. So that is how you write your justification. So then, what can you say about the output, f of x? I'm gonna say f of A. Okay, so where can we look at our output? Right here. This is right here. Right, when it crossed the graph. Here it crossed the graph. So our f of A is negative value, and this is our function of B. Okay, so what can you say of f of A? F of A is less than the function of B, right? Because the f of B is right here, and f of B is positive, and the f of A is negative, okay, where it hit the graph. So in this case, this is increasing. Why? Both are less than. If both are greater than, increasing. But one is increasing, the other one is decreasing, then it is decreasing. Okay? I hope you understand it better this time. Let's look at graph E. Okay. If we look at this going this way, we could tell right away that this is decreasing. But our problem is how we are going to justify it. Reason why you say it's decreasing. All right, let's do this. So we would say that f, the function, is decreasing. Because by looking at the graph, you know right away that it's decreasing. So how would we say in the interval? So you start saying that in the interval. What is our interval here? This is 1 to 6, right? So our interval is between 1 to 6. In the interval from 1 to 6. That's how you're going to write your interval. Then you would say because for all. Please remember this because this is how you justify your answer. So you start hitting at A and B because for your all A and B in the interval, so when say in the interval, you look at the the x axis or the input values. Okay, so let's look at our A is 1, our B is 6. So what can you say about the A? Is A greater than B or B is greater than A? Of course, A is less than B because 1 is less than 6. So you say if A is less than B. Okay? Then, let's see it. Then, what can you say about the function? I put it there. Function of A, function of B. I leave that space. Okay. Our A1 hit the graph. Okay. This is our function of A in the y-axis. All right. It is found in the positive. It's positive. While our function of B, we go down, then we hit the y-axis. So it's below 0. So this is f of B here is negative. That means the positive is the function of A. Okay? That is on the, it's greater, right? Because positive is greater than negative. That means the function of A, oh, I have written it already here. Function of A is greater. Right here. Greater than the negative. So, greater, less than. That's why it's decreasing. Because if both are less than or both are greater than, then it is increasing. Okay. I hope this is clear. This is a review questions class. I mean, everyone. I almost forgot. I'm thinking I'm talking to my class. Okay, let's do letter letter F. All right. So what can you say about it here? Is it increasing or decreasing? Now, what we're going to do first is we have to look at the interval. A to B. Okay? So, A is less than B. All right? Sorry. How about the f of A? F of A is here. Then I hit the graph here. The f of B is here. Okay, I want you to look at the situation. Is the function of A greater than the function of B? Function of A is above B. That means the function of A is greater than the function of B, right? So if this is, for example, this is 10, and this is in the level of 5. So 10 is greater than 5. So what can you say about it? Is it the other one is decreasing and the other one is less than, the A is less than B, but the function of A is greater than B. So is it increasing or decreasing? The function is decreasing because one is greater and the other one is less than. Okay? Is decreasing in the interval. So you write the interval from 5 to 12. Okay, that's your interval. Because for all, so this is your statement. Because for all in the interval, interval for all A and B, I forgot. All right, in the interval, if what is our A? A is less than B. 5 is less than 12, right? Then you have to say about the function this time. Function of A is greater than the function of B. So 1 is less than, the interval is less than, but the function is greater than. That means the function is decreasing. Okay? I hope everything is clear. All right. Let's have the set C. Type of questions like this is very popular. Might as well we might think, is this coming out in the test? Who knows? But you have to be prepared. C. Use the graph of F to answer the following questions. So try to inspect before answering any of the questions. Do an inspection of your graph and relate it to the questions before answering it. So in A, it is, you see the term concave up. In B, you see the term in concave down. C, you see the term increasing. D, you see the term decreasing. And E, you see the term zeros. And F, you see the term y-intercept. So these are the elements of the graphs in the function. Okay? Elements. Concave up, concavity, you have increasing, decreasing, or zeros, y-intercept. These are the very common, and these are the terms that is related to in this, in this chapter, in this lesson, which is in the chains in tandem. So don't forget this stuff because this is very important. All right, let's look at our graph. So we see concavity in the graph. So we see this right here. So we see that this is concave down, and this is right here going up is concave up. All right, facing down and facing up. So we can see from here to here, it's increasing. Then from here, it started to move down. It's decreasing. And then it's increasing again. Okay, that's one thing you have to see. Zeros, where it intersect at the x. This is our x here. So we can see this point right here. It intersect at the x. And y-intercept intersect at the y. So there is a point right here. Okay? So I think you are ready to answer the question. On what interval interval or intervals in the graph is concave up. Okay, when it starts to go up, isn't it? We try to look at this way right here, here until there. It starts to go up. So that means our x value right there, it started to go up when x is greater than c. From c up. Okay? On what intervals in the graph is concave down? Okay, where's the concave down? From here, going there. From here, going down. Right? So, when x is less than c, so where is the x less than c? Right here, going that way. It start to go down. Okay. When is the graph increasing? I was showing it to you here, increasing, and it's also increasing right here. So where is that when it increase? Because this portion right here is not increasing, only from here to here. So when x, where is that point? Going there to the left. When x is less than b, right? That's the one it's increasing. What else? It increases from here going up, going there. So when x, and there is another part that is also increasing. Oops, I erased this stuff. Intervals is the graph. All right. So, and it increase like when x is greater than d. Okay. I really would like to erase all my writings here. I would like to make it clear so that it will be nice to your eyes. I will do it again. Okay? So, concave up. Right here, this is up. So, it is from here greater than c. So, this is going down. And this is going up right here. This is going up. All right? Up. This is going up. This is concave down. I will not use the up terms. Increasing. Increasing. Decreasing. Increasing. So when x is less than c, so where is x less than c? Somewhere here. That is concave down. But when x is greater than c, it is concave up. Okay? Here. Then when is the graph increasing? From here to here. So when x is less than b, so this is less than b, and x is greater than b, x is greater than d. This is the portion right here that is increasing. On what intervals is the graph decreasing? Only from here to here. It's decreasing. So what is the interval? From B to D, right? From B, where is B? Right here, to D. It decreases. So the interval would be from B to D. So where is the 0? 0 where it intersects the x-axis. So the 0 would be when x is equals to a. How about the y-intercept? When it intersects the x-axis, the y-axis. So when it is, see that? E, when y is equals to e. All right, that's it. Question 2. Another graph. So we see a concave up. Then we see a concave down, increasing, decreasing, y-intercept, zeros. Okay, so we can see from here, this is decreasing, increasing. We can see a decreasing right here. This is concave up. We can see a concave down. All right. So when is the graph is doing a concave up? Sabing. The graph is concave up. Isn't it from here to here? That means this portion right here is concave up. So when the x value is less than c, it starts to go up. Okay? When it's concave down, so concave down started from here when the value is greater than c. It's concave down. When is the graph is increasing? Right? When started to increase from here, because from here to here, that's decrease. But it increased from here. So do we see any increase only between B and where it's still increasing from here? Right? It's increasing. So what interval it is increasing? Isn't it from B to D? Okay, from B to D, it's increasing. How about decreasing? Okay, we can see 2 decreasing here. Decreasing. This is also decreasing. So when x is decreasing, when x is less than b. Right? When x is less than b, it's decreasing. And we have another one that is decreasing when x is greater than. You see this? From here to here. That's decreasing, but the x value is greater than d. Point D. Okay? Do we see zeros? Okay, I'm gonna use another color here. Let's say I'm gonna use this color. Where it hit at x axis. This point, the graph passes through the x-axis, and this point right here. So we have 3 zeros. All right. Let me change the color here. So we have when x is at point A, when x is at 0, And when x it is at this point right here, it's at point E, right? And the y-intercept, if this is x-intercept, this is also y-intercept. The point where it intersects the y-axis. So it happens to be when y equals 0. All right. When you do in the test, be sure you mark all the important features in the graph. It will be easier for you to do this. Mark your graph, that is the given graph, so that you can understand each term and then mark your graph. Do the same way as I did and it will be easier for you. Let's do graph number 3. On what interval? Concave up, concave down, increasing, decreasing, y-intercept, zeros. Hopefully you have mastered this thing up already. But we don't have a number. It's like G, H, I, J, K, L, M, N, O. These are your points. Okay. So we can see here. Let's look at decreasing. Increasing. We can see increasing. And there is a decreasing somewhere right here. It's a more, this is concave up. And we can see a small concave down right here. Concavity. And there is another concavity right there. So we have concave up and concave down. Okay, we'll start with concave up. When does it start at concave up? I think from here, when x value is less than I, it's concave up. On what else? It start to up. L going there. It start to go up. So when x is greater than L. Oh, I will just make, okay, I'm gonna write that L that way. L. Okay, and what interval is it is concave down? On what interval it's concave down? Right here. We could say it's, if this is started to, concave up, that is less than I. So we could say starting from I, the interval, to L. This is L, and this is I. So in between this interval, you could see the concave down. Right? So it will be the interval from I to L. That is concave down. Okay. Next, when it is increasing. So when it starts to increase, isn't it this one start to increase, right? From H, then it increase going to right here. This interval, H and K, right? It start to increase. So from the interval of H to K, it increase. What else is increasing? right here, it's increasing. So starting from here, going up. So when x is greater than n, that is increasing. Okay. Next, let's look at decreasing. Okay, we can see it here. Decreasing. So if h is decreasing, how about less than h? The x less than h. That is the where the decreasing is happening. So when x is less than h, that is decreasing. Any other one, any interval that is also decreasing? Let's look at here. Okay, I see a decreasing before going up, before doing a concave up. So I see from k to n. So that's a small one right here. When the interval between from k to n. This is k right here, and this is n. So this small thing, this curve, started to go down, started to decrease before it goes up. So zeros. Oops. I'm going to use another color for zeros to make it clear. Where it hit our x-axis, this point. So what is that point? G. So when x equals G, what else did it hit? J. It hit at M. And it hit at O. At O. So so when x is at G, when x is at J and at M, and the last one when at O. These are your zeros. Okay? The point where it hit the x-axis. For y-intercept, only one point right here. Right here. Y-intercept. So when y is equals to p, where it intersects the y-axis. Alright. Let's do the last part. Of course, in a test, there is a multiple choice. Alright. But be sure, I usually, when I was a student, I really like to do elimination. So when I eliminate the choices that are not, it's very clear that that's not the answer, then it will be easier for me to get the target or to get the right answer. So let's do this. How does the concept of concavity? Be sure you underline the term that will let you understand the question. So concavity is there, relate to the rate of change in the function's behavior. That means it's saying about rate of change. Is it decreasing or increasing? Okay? Rate. Increasing. That's the thing that will come out to your mind. Decreasing. So let's look at A. Concavity only affects the function's behavior at the inflection points. You would say, oh, inflection point. This is not the one. Concavity, like inflection point, is a different thing. You know, that point is the one that divides the concave up or concave down or concave down or concave up. Okay, but it's not talking about the rate of change. It says relate to the rate of change. Concavity is inversely proportional. Inversely proportional to the rate of change, you can eliminate that. It's not talking about the inversely proportional. Concavity determine the absolute value, or the term absolute value. Far from that of the rate of change. It's asking relate the rate of change, not talking about the absolute value. So what is left? Concavity indicate whether the rate of change is increasing or decreasing. There you go. You have the answer right there. So, concavity, what does it say? Concavity is a curvature. The curve, right, of the function. You could go back to the definition of the concavity as how the slope changes. Slope is the rate of change. That is what we mean by, talking about concavity. Let's have question number 2. In what way the zeros, so I will underline the zeros, of the function provide the insight into a graphical representation? So you might think, oh, what does zeros represent? So I would just write it. If you are in the test, write it. Zeros, like, oh, it represents the x value, right? Where what the output, the f of x, is equals to 0. Or when you say the y is 0, you have the x value. And that is what we mean the 0. Okay? So what do we have in the choices? Zeros determine the maximum height? No. Because zeros can be found in the x-axis. It's not talking about the height. Okay, that's a big no thing there. I'm doing something like, it's not talking about the height. Zeros always occur at the vertex of a parabolic function. Parabolic function, vertex. Let's say if we have parabola, so it intersects at the y-axis, so it's not a 0, so that's not a thing. 0 exclusively, it says exclusively, define the end behavior. That's a no. End behavior, that is when your graph is like that, you are talking about the end behavior of the graph. That's a no. Zeros indicate where the function's graph intersect at the x-axis. Of course, that's your answer. Right? Very easy choices. You know right away which is the right one. What I'm doing right here, I'm showing you how to do the process of elimination. And if you are used to doing it, practice doing it, and then it will be easier for you. You will do great when you are given a multiple choice question. Let the function f be defined as a function that is always decreasing. So our function here is always decreasing. Okay? The table shows the value of function at selected value of x. Which of the following represents the possible value for a? Okay? A. A is found in the output. A is here. A is here. It's in the output. So it says in the interval between -5 to 7, right here. Is A found in the input? No. B in an interval in -2 to 0. -2 to 0 is right here. No. Right? 0 to 3. Right here, 0 to 3. No. So what is left? You have only D and E. Okay. So if we look at D, -2, the interval -2 to 4. So if we do -2, -1, 0, 1, 2, 3, 4. This is our, so the A value is somewhat from here, right? That's for D. If we try to look at E, is from -15 to 12. So if we say -15, -14, blah, blah, so on, until we come up with 12. So the possible value for A is between here, 11, positive 11, right? But, say but, a -2 is already containing in this interval right here. Right? If we do that, possible value of A, it cannot be 15 and it cannot be 12. And the rest of the numbers that are between 12 and 15. So that means our possible value of A is, okay, the function of f at selected value of A is between -2 to 4. That is the possible value for A. All right, we have 2 more questions. Use the graph F. Okay. The figure shows the graph of the function. Let A, B, C, D, and E represent the x coordinates of those points of the following, which is the point of inflection. If I don't have, if I just look at the graph, I could tell right away which is the point of inflection. Okay? I could tell right away which is the point of inflection from the definition itself. It is the point where the concave up, change to concave down, or it divides the up and down. So if I look at the graph, I could tell right away that this is the point of inflection. C, it divides the up and the down. But if you do it like the point of elimination, so I could say that, you know, is it at point A? No, because at point A, this is the point where the concave up is found, or it belongs to the concave up. It cannot be. Is it at point B? It's still at the concave up. Point D, it's still in the concave down, as well as E is a concave down, except C. All right, it's very, some questions are easy by just looking at the graph. 5. The figure shows the graph of a function A, B, C, D, and E. Okay? Represent the x-coordinate at this point of the following, on which interval is decreasing on the graph of the concave down. Okay? Concave down, decreasing. So we're not going to look at this part right here. We'll just look at the concave down. All right? If we look at the interval from A to B, it belongs to the concave up. B to C, it still belongs to the concave up. The interval from C to D, okay, let's leave that. The interval from, sorry for that. The interval from D to E. D to E. And none of the above. Okay, there must be answer. So we'll talk about the interval from C to D. C to D, if you look at that, it's increasing. All right? The only one that is decreasing is from D to E. We are talking about decreasing. So C to D is not decreasing, but it is increasing. So you can eliminate that right away. So our answer would be the interval from D to E. Okay? Because this is where the decreasing of the graph. All right, I hope we did how many questions? I think 10 questions. I hope this helps a lot. So when you start, taking the AP Precalculus exam, you go back to this video and check from lessons to lessons, because that is what I'm going to do. After a lesson, I do a review questions, and I think you will be good for taking the AP Precalculus exam. And I would like to say this: if I can do it, so can you. Okay, don't forget to like this video and hit the subscribe button.